Okay, this unit is stoichiometry, and stoichiometry is the first unit where we're going to be applying everything that we learned how to do in quarters one and two with writing formulas and balancing equations. So you can do stoichiometry if you go back and make sure you know how to write a formula and balance an equation. So that's your first order of business if you still don't know how to do that. Stoichiometry is the relationship between the relative quantities of substances taking part in a reaction forming a compound. And typically, it's a ratio of whole integers. So it is how we decide how much of the different reactants that we need in order to create a certain amount of product, or we could figure out how much product we need first and then determine how much of the reactant we need to make that product amount happen, or vice versa. So we could figure out either direction, how much we need to make the product or how much we need to make the product. So it's a really important part of chemistry. So when you are going to do stoichiometry, you first have to balance the equation, hence my warning about making sure you know how to write and balance an equation. You have to figure out what you have. We call that in this template that we're going to make the given. So usually the given is a number, and it's going to be what your starting point is for any problem that you have. Then you've got to determine, what do you need? What are you trying to find? What is the question asking? That part is always going to be found in the form of a question in the problem. So they're going to ask you a question. That's what you're trying to find. I typically write the letter G over top of the number they gave me, and I write a letter F over top of the quantity that they're asking me for in my question. So the limiting reagent stops the reaction. So that's a vocabulary word. The thing that limits the reaction is the thing you're going to run out of. Okay, so we'll talk about that in a minute with some easy examples, but it's super easy. If you ran out of it, it was limited. So it's the limiting reagent. It stops the reaction. And the excess reagent remains after the reaction stops. So whatever you have that you haven't used up is called your excess reagent. Of course, in a perfect world, you don't have excess reagent. You've used it all up. So if you're doing stoichiometry for a company, then your goal would be to make sure that you don't have an excess reagent, that you give them the right amount of each of the reactants in order to create the quantity that you're looking for with as little waste as possible. And we're going to use our tool that is on the bottom of our mole. And I'll go over that again. So you might want to write that down in your notes, um, the template that we're going to be using to solve the problem. All right, so you take what you've been given, you use what you know, which are conversion factors, and you get what you need, which is what we're trying to find. So the mathematical calculation that you make is called the theoretical yield. In theory, it's what you'll make. Now, that means every math problem, the answer is called the theoretical yield, just a fancy word meaning what you should make, the theoretical yield. It's not often what is made. There's lots of reasons why, but what your answer to your math problem is called the theoretical yield. So the formula that's on the belly of your mole, if you remember, if not, write it down, is the number that is given in the problem. So they're going to start you out with some question, and there's going to be a number provided. That goes in that first spot. And that's over the conversion factor from the box. The box is also on the belly of the mole. It's your conversion factors that you needed to do mole conversions. For example, they're the number 22.4 if you have liters of a gas. It is 6.02 times 10 to the 23rd particles. And it's the molar mass of the item if you're dealing with mass. And remember, we're going to round those numbers to the closest whole number. and or it's the number 1 if you're dealing in moles. The coefficient of what you're trying to find. So this is why it's important that you know how to balance an equation, because you'll have to write a chemical equation sometimes, but most of the time they give you the chemical equation. And once you write and balance the equation, you're going to have coefficients. The coefficient of what you're trying to find over the coefficient of what you're given gives you what's called the mole ratio. So that's part of our equation. And then the number from the box, once again, that's the conversion factor from the box, 22.4, 6.02 times 10 to the 23rd, molar mass, or the number 1, for whatever number that you are trying to find. And then the number 1 is part of the equation. So you always start with the number that they've given you. We talked about that when we did molar conversions. The first number in your calculator is going to be the number that they provided to you. And then, so the first whole fraction of this equation is about the thing that they gave you. The middle section is the find over the given's coefficients. And the way I memorize that it's in that order as opposed to the given over the find is because F comes before G. That's how I memorized which coefficient goes first. And then the end of the problem, you're all heading towards what you're trying to find. So you start with what you're given, the middle converts it over, that's find over given, and then you end up with the find in the end, and that's going to solve your problem. So the formula on your mole, let's make it into just letters A's and B's right now so that we can talk about how to set up that equation in our calculator. So the easiest way to perform this this calculation is to go A times B times C. So just go directly across the top row of your equation. When you get to the end of the line here, you're going to hit equals. I should have put that in there, so let's write that in there. You're going to put equals, and you're going to then hit the divided sign, okay, equals divided by, and then you're going to open parentheses. The only time you don't need parentheses around these two things is if one of them is the number 1. Otherwise, you need to open parentheses, and then do D times E and close the parentheses, and then hit equal sign. And the answer is going to be in the units that you were trying to find. You could write those units on your answer before you even start the problem. So the answer comes out in the units that you're trying to find it in, okay? So if you have something that's in scientific notation, they go in their own set of parentheses. So let's say letter D is the number 6.02 times 10 to the 23rd. If you have a number that you have written with the E format, that's okay. You don't have to actually put that in parentheses. But if you're using the method and your calculator requires you to have times 10 and you have the little caret thing to the 23rd, if you're writing a number in scientific notation, then that number, the 6.02 times 10 to the 23rd, has to be in its own set of parentheses, which means you're going to open a parenthesis, you're going to open another parenthesis and put your 6.02 times 10 to the 23rd in it, close that parenthesis, times whatever number you have here in the E position, and then close the parentheses. So anytime you have a number that's in scientific notation, give it its own set of parentheses. Then you won't mess up and your answer will come out right every time. All right, so the numbers in the box, write these down. They're reference numbers from our molar conversion unit. So if you are using or converting to or from moles, you are going to use the number 1. If you're converting to or from liters, the magic number is 22.4. Remember, this only works if the substance is a gas. And for this unit, you don't need to worry too much about whether or not what they gave you was a gas, because we don't have that ability yet to determine when we write our own formula. If they ask you for liters, go ahead and assume that it is a gas for this unit. But in the future, that's not always the case. And then for pieces, molecules, atoms, particles, however they give you that aspect, it's 6.02 times 10 to the 23rd, which I prefer the 6.02 E23 method in my calculator, because when you use the capital E and do the E to the 23rd button, your calculator knows that that number is in scientific notation and already gives the parentheses. So if you're using the method that's listed here, 6.02 times 10 to the 23rd, please put that in parentheses every single time. And the molar mass is the only one you have to actually look up. And remember that when we look up molar mass, we are using the numbers on the periodic table rounded to their closest whole number. Except for chlorine, we use 35.5 grams per mole. All right, so let's give an idea of what the problems are going to look like. So solid iron 2 sulfide is burnt in the presence of oxygen gas and produces iron 3 oxide powder and sulfur dioxide. They're going to ask you, if you've been given 5 moles of oxygen gas, find the number of moles of iron 2 sulfide needed to make your sulfur dioxide. Now, the first thing you have to do is write and balance an equation. So here we have to write an equation. So I've got solid iron 2 sulfide. So FeS, okay, is burnt in the presence of oxygen. That's a combustion reaction, so plus O2. Don't forget, oxygen gas is diatomic. And it produces, so that's the production arrow, iron 3 oxide. So that's Fe gets the 2 from the oxygen, O gets the 3, and sulfur dioxide gas, so plus SO2. Okay, so here's my equation to start out with. So the first step is to be able to take words, the English language, and turn it into chemistry. So I've got my equation, and then I need to balance my equation. I balance it with my coefficients. This unit is not about writing or balancing equations, so we're not going to spend a lot of time writing or balancing equations. If you need to figure out how to write an equation or balance an equation, you need to go back to those units and look up how to balance equations and how to write equations from the past modules. Okay. All right, so we've got our equation, and we're going to use our our template, and we're going to solve this problem. So the first thing is you always start out with the number given in the problem. So the question gave me 5 moles of O2. Okay, so 5 moles of O2 is what's going to go in that first spot. The number given from the box for the units. So this is in moles. So when you have something in moles, the conversion factor for that is the number 1. The coefficient of what are you trying to find? So what are you trying to find? They asked you to find moles of FeS. Be careful. You see how SO2 is also listed here in this problem, but that's not the question. The question said, find the number of moles of FeS needed to make SO2. So what you're trying to find is the moles of FeS. So that is what I'm trying to find. That's the coefficient of what I'm trying to find. So I go up to the problem, and the coefficient on the FeS is a 4 over the coefficient of what they gave me. So the coefficient of the number that they gave me was oxygen. So that's why I have a 7, because the coefficient on the oxygen is a 7. The units I'm trying to find it in, they asked me to solve it in moles. The conversion factor for moles is a 1. So I use a number 1. Now remember, in our calculator, we're going to go straight across the top. We're going to get to the end of the row, and we're going to hit equals. We're going to hit the divide sign. We're going to open up parentheses and do the bottom of do these 2 numbers. Now in this time, I don't actually need parentheses, because remember I said the only time you don't need it is if one of the numbers is 1, because I'm not going to actually put any ones in my calculator. So if I multiply by 1 or if I divide by 1, I don't do anything. So I leave those like they don't even exist in my mind. So in this problem, I've got 5 times 4, that's my top row, equals, so your calculator should now read 20, divided by 7. So when we're solving these problems in class, you need to be holding your calculator in your hand and doing the calculations. Do not be a spectator, because that's how you're going to find out whether you're pushing the right buttons, using parentheses correctly, etc. So make sure you're playing along. Okay, this is not a spectator sport. You have to practice that. So when I do my equation after I get my 20 and divide it by the 7, your answer should come out to 2.86 moles of FES. Now, let's talk about significant figures for a second. Because they gave me a 5, my answer actually is going to be 3 moles of FES. That's because the number 5 is just one significant figure. And so when I get my 2.86, it actually had more numbers after that, I'm sure. You need to get it to the right number of significant figures. All right. All right, so we've got this question here. Solid iron 2 sulfide is burnt in the presence of oxygen and produces iron 3 iron powder and sulfur dioxide gas. It's the same equation, so it balances the same way, but I'm asking for a different question here. It says you've been given 5 grams of oxygen, and I want to find the grams of FES, okay? So when they ask you for a different unit, the conversion factors are different. So let's set this problem up. So this number here that they're giving me is still going to be the number 5. Number given in the problem is 5, but it's in grams now. So the conversion factor in the bottom box is now the molar mass. The molar mass of what they gave you, which is of oxygen gas. So that's where this 32 grams of oxygen is coming from. The coefficient of what I'm trying to find, I'm still trying to find FES, so that's still a number 4, over the coefficient of what I was given, which is still oxygen, so it's still over 7. The number that I'm trying to find it in, and oh, this should have a 7 here. Sorry, there we go. This number here is in grams of FES. So then I got to go look up the molar mass of FES. That's a 1 Fe and 1 S. So that's where this 88 is coming from. It's Fe, which is iron, which by the way is 56. We're rounding to the closest whole number. And then S, which is 32. So that's where I'm getting this 88 from. It is 56, the iron's mass, plus the sulfur's mass. Okay, so that's where the 88 moles, grams is coming from per mole. All right, so in my calculator, I'm going to hit 5 times 4 times 88. I'm going to hit the equal sign. Then I'm going to open parentheses. I'm going to put 32 times 7, and then I'm going to close the parentheses and hit equal sign again. So do that in your calculator, and I'm going to show you what the answer should be. So 5 times 4 times 88 equals, divided by, open parentheses, 32 times 7, close parentheses, equal sign. You should come up with 7.86. It's one significant figure again, because it's 5 is a whole number there. So that means it's 8 grams of FES for this particular question. Okay. All right, so solid iron 2 sulfide is burned in the presence of oxygen gas and produces iron 3 oxide powder and sulfur dioxide gas again. Same equation, but now they're asking you to solve for liters. We're just looking to see how the different units change the different conversion factors. All right, so now my setup of the problem, I still am setting up with 5 liters this time. However, because I'm solving for liters, the number from the box, the conversion factor for liters, is 22.4. The coefficient of what I'm trying to find is still 4, and the coefficient of what I was given is still 7. And I'm trying to convert it to liters. Now, this I'm going to show you. I have some numbers here that are on the top and the bottom that are the same. And it doesn't matter which one of these fractions they're in. If you have a number on the top and the bottom that are the same, and that goes for any of these other boxes, you cross them out because 21.4 over 21.4 is 1. So that doesn't even exist in my problem anymore. But you could put it in your calculator. It is no problem. It will solve out exactly the same if you use your parentheses down here on the bottom. But this turns back into 20 divided by 7 again. But if you wanted to, you could do 5 times 4 times 22.4, hit equals, open parentheses, do 22.4 times 7, close parentheses, and equal sign, and you're going to still get 2.86 liters of FES. Now, how do I know what the units are going to be on my answer? It's whatever they asked you to make, okay? So don't forget those units. They are definitely part of the answer. The way the units are written is there's a number, then there's one space between it and the unit of measure, and then there's one space between it and the chemical compound of what you're making. All right, so you don't need this of that's listed here because this was from a sentence, how many liters of FES are needed to make SO2. You don't write the letter OF in the units. All right, so now we're going to do particles. So number given from the problem is 5 times 10 to the 24 in this particular problem. And the number for particles is 6.02 times 10 to the 23rd. The coefficient of what you're trying to find is still going to be the 4, and the coefficient of what you were given is still the 7. The units that they're asking you to solve it for is in particles, so 6.02 times 10 to the 23rd. Now, the nice thing is when they give you particles and ask for particles, or if they give you liters and they ask for liters, you can cross those out. So those don't have to actually be in your math problem, and you're going to be back to 20 divided by 7. However, you can put this all in your calculator. Remember, anytime you have a number in scientific notation, so it's best to always kind of write your problem out first, is it needs to go in parentheses. So 5 times 10 to the 24 times 4 times 6.02 times 10 to the 23rd equal sign. Now, because those are all being multiplied, the top row, technically speaking, didn't have to have parentheses. But my rule is if you don't remember when to put it on it all the time so that when you do need it, you have it. So when you get down to the next thing, you still need your own parentheses around these two numbers. So you're going to have two sets of parentheses. And then you'll have to close the one around the 6.02 times 10 to the 23rd, and then you'll say times 7 and close the parentheses that you opened to begin with here. So the bottom gets its own parentheses around a number in scientific notation. All right, so my answer is going to come out to 2.86 E24 in 2 sig figs here because they gave me 5.0. So that means I need 2 sig figs. That means my number is 2.9 E24. So the E24 part, this piece, is not part of your significant figures. Just the original part of the number is what you have to work out to get it into 2 significant figures. So they gave me 2 sig figs. My answer comes out in 2 sig figs. All right, now it's asking a different problem altogether. And they've given me an equation. They've given me copper and nitric acid form nitrogen dioxide, copper 2 nitrate, and water. And they've given me a balanced equation. They're asking me if I've been given 2.7 grams of copper, find the grams of NO2 that you're going to want, that you're going to make. So I already know that my answer is going to come out in grams of NO2 if I do this problem correctly. So you could already start out by writing out your units before you even begin a problem, okay? So don't let the units be what's holding you up. You already know you're trying to find grams of NO2. All right, so start out with what they gave you. It's always going to be the number. So they gave me 2.7 grams of copper. If they give you grams, the conversion factor is the molar mass of copper. So you got to go look up copper on the periodic table, round it to the closest whole number. That gets me 64 grams of copper per mole. This is the coefficient of what I'm trying to find. I always kind of write myself a little letter when I'm writing out my equation. I say find over given. And so my coefficient of what I'm trying to find is the coefficient on the NO2. I can look to my units that I already wrote when I started to figure out what am I trying to find. So the NO2's coefficient is a 2. Okay. Over the coefficient of what I was given, I always write 2 sets of units down. I actually don't usually write any of the rest of these units that you're going to see in this problem. I only ever write the units of what I was given and the units that I'm trying to find because I don't want to lose track of those 2 things. Okay, so the coefficient on what I was given is copper. So copper's coefficient is a 1. And the units that I'm trying to find it in is grams of NO2. So I've got to go look up on the periodic table the molar mass of nitrogen and the molar mass of oxygen. And I got to add those up. That is where I'm getting this number of 46. And then over 1, everything's over 1. All right, so in my calculator, remember we go across the top row. We get to the end of the column and we say equals. We open parentheses and we do the second thing. Now, you'll notice I don't really need parentheses again, but if you think math is not your friend, just do it the same way every single time. It doesn't hurt by multiplying it by 1. That way you don't mess up and you start getting into the habit of putting these parentheses, which are going to save you. Okay, so 2.7 times 2 times 46 equal sign. Put that in your calculator. Divided by, because we're going to get to the bottom here, open parentheses, 64 times 1, close parentheses, and I end up with 3.9 grams of NO2 as my answer. Now, they gave me 2 digits, 2.7, and my answer's in 2 digits here, so that is the correct number of significant figures. You don't have to have the word of, and generally we don't write the whole word grams out. The units would have said grams space NO2. All right. So, given 2.7 grams of copper, find the moles of nitrogen dioxide. So, 2.7 grams of copper over the molar mass of copper, 64. The coefficient of what I'm trying to find is still 2 over the coefficient of what they gave me is still 1. The units I'm trying to find it in now, though, is moles. So that's a number 1 over the number 1. And when I solve this problem, it's 2.7 times 2 divided by 64. Now, if you want to become a creature of habit, make sure you put this bottom thing in parentheses. So 2.7 times 2, go ahead and put times 1 if you want. Hit equal sign, open parentheses, 64 times 1, close parentheses, equal sign. So if you have trouble with math and you don't know when to do which process, do it the exact same way every single time and you will get the answer correct. So the answer is 0.84 moles or 8.4 e to the negative 2 moles of NO2. So they gave me 2 digits. My answer is 2 digits. Now this is 2 digits because when I put it in scientific notation, that means move the decimal till there's one number in front of it. It's 8.4, which is 2 sig figs. So these zeros here in this problem right here don't technically count against your significant figures because that's the 2 digits that you would have if you solve the problem. Now, when you look in your calculator window, you might have a lot more numbers than this. How did I know I wanted to put it to 2 digits? The question told me. The question of 2.7 told me the significant figures. All right, so given 2.7 grams of copper, find the number of liters. So 2.7 grams of copper, I still have 64 because that's from the conversion factor. The coefficient of what I'm trying to find over the coefficient of what I was given. Now the units I'm trying to solve it for here is in liters, so that's 22.4 over 1. So in this problem, 2.7 times 2 times 22.4. You're at the end of the road, so you hit equal sign. You open parentheses, 64 times 1, close parentheses, and equals again. And the answer comes out to 1.9 liters of NO2. So that's two significant figures. Your calculator is going to have more numbers than 1.9, well, most likely. You are picking two sig figs because the question gave you two significant figures. All right, so given 2.7 grams of copper, find particles. So you'll see they're just changing the conversion factor here. So I'm going to have 6.02 times 10 to the 23rd particles in my equation. Now remember, if you're using the E button, you're okay to not put numbers in scientific notation in parentheses. But if you're using times 10 to the 23rd buttons, you need to put that in parentheses of its own. Okay, so mostly when it's on the bottom, but I'm doing it always so that people that are having difficulty with math know. When you're multiplying it, you don't need it, but when if we're here on the bottom, you would. But I want to instill the habit of if you don't know, always put a number in scientific notation in parentheses. All right, so 2.7 times 2 times 6.02 times 10 to the 23rd. I'm at the end of the road, so I hit equal sign. I open parentheses, 64 times 1, close parentheses, equal sign, and my answer is going to come out into two significant figures. Okay, 5.1 times 10 to the 22. This piece is usually so small at the end of your calculator window. It's way down here, and sometimes it's like super microscopic. Hey, please, on this unit, always check all the way down there to see what numbers you have, because if you just said 5.1, needless to say, that's going to be wrong. That's a big difference from 5.1 times 10 to the 22. All right, so I've got solid potassium chlorate decomposes. So this is sodium potassium chlorate decomposes, so that's the reaction arrow, into potassium chloride, and oxygen gas. So this is the written equation for this problem. How many moles of oxygen? So this is a question. How many moles of oxygen? So that's what I'm trying to find. Can 6 grams of KClO3 decompose into? So that's the number that they've given me. So this piece right here is the given in the equation. So the question is always the find. See how many moles of O2. Can 6 grams, the number that they give you, is always associated with the given. So what are the units on my problem going to be when I solve this? Moles of O2. I can already write that right now. I could already write moles of O2 because that's what they asked me to solve for. So some of you are constantly getting units wrong. I already know what the units are before I even start this process because that's what it asked me to solve for. All right, so the first thing I'm going to do is put the number that they gave me. So 6 grams is my given, and what I'm trying to find is moles of O2. So 6 grams, if they gave me it in grams, that means convert to molar mass. So I got to go look up K, Cl, and O, and I got to get 3 O's there. And remember, the Cl is 35.5. It's the only one we don't round to the closest whole number. So the K was 39, the Cl is 35.5, and then I have 16 times 3 that I have to add together. So 39 plus 35.5 plus parentheses 16 times 3 equals, that's where I'm getting 122.5 grams of the potassium chlorate. The coefficient of what I'm trying to find. What are you trying to find? So you're trying to find moles of O2. So the coefficient off the O2 over the coefficient of what you were given. Well, what did they give you? They gave you the potassium chlorate, so that's over 2. The units that you're trying to find it in, they told you to find it in moles. The conversion factor out of the box for moles is the number 1, and then over 1 all the time. So that's 6 times 3 times 1 equals divided by parentheses 122.5 times 2, close parentheses. So solve that problem in your calculator. Then let's talk about, you're looking in the calculator window, how many digits are you going to have in your answer? Go back and look at the original problem, not what you necessarily wrote, because you'll see I edited the 6.0 and just wrote it 6 because that's exactly the same number in my calculator. But 2 digits is what my answer has to be in. So the answer is 2 sig figs. So that's why I'm going to keep the first 2 digits that I come to in a decimal number. So I'm keeping the 7 and the 3. And that's 7.3 to the negative 2 if I'd like to put that number in scientific notation. Maybe you say, well, I don't like to put that number in scientific notation. Well, here's the problem. You do have to know it's either one of these, because some questions are going to be multiple choice answers, and you have to know that 0.073 is the same thing as 7.3 times 10 to the negative 2. Those are the same number. All right, theoretically, how many atoms of O2 are produced from 6 grams of the potassium chloride? Okay, so now my units that I'm solving for, what am I trying to find, is atoms of O2. So that's what I'm going to write over here, atoms. That's my units of O2. Okay. So this is the number that they gave me, which is 6 grams, and I'm trying to find atoms of O2. So 6 grams over the molar mass, the coefficient of what I'm trying to find over the coefficient of what I was given. The units I'm trying to find it in now, though, are atoms, so that's the conversion factor for atoms, times 1. So multiply across the top row, 6 times 3 times 6.02 times 10 to the 23rd. You're at the end of the road, so equal sign, divided by parentheses 122.5 times 2, close parentheses. And your answer is going to be in 2 significant figures, so 4.4 times 10 to the 23rd, times 10 to the 22nd atoms of oxygen. So theoretically, how many grams? So now we're going to be solving for grams of KCl are produced when 7 liters of that decompose. So this is a different problem. Same equation, I believe. Let me look back. Yeah, same equation, but they're asking you to solve for different things, and they've given you a different thing. They've now given you 7 liters of this business, and you're solving for grams of KCl. All right, so I know my units for my answer is going to be in grams of KCl. I already know that because that's what the question asked me. How many grams of KCl? So my given is 7 liters, and my find is grams of KCl. So if they give you something in liters, what's the conversion factor for it? 22.4. The coefficient of what I'm trying to find, that's 2. Over the coefficient of what I was given, that's 2. Over then times the units that I'm trying to solve it in. I'm trying to solve it for grams of KCl. So I got to go look up the molar mass of K and the molar mass of Cl and add them together. So when I do that, that is where this number 74.5 is coming from, over 1. Now, if you're great in math, or even mildly good in math, you know that 2 over 2 doesn't exist anymore in my problem. So you could just cancel that out. It won't hurt anything if you do it in the problem. So if you don't notice that, that's fine. You could do 7 times 2 times 74.5. You're at the end of the road there, so hit equal sign. Divided by parentheses 22.4 times 2 and end parentheses. And you're going to answer is going to come out to 2 significant figures because they gave you 2 significant figures. 7.0 is on purpose 2 significant figures, because if they wanted to give you 1 significant figure there, they would have just said the number 7, and they didn't. So you have to give them 2 digits in your answer. So 23 grams, or 2.3 times 10 to the 1 grams of KCl. All right. Hopefully by now you understand what you need to do, and you can go solve any of those problems that are in your practice assignment. I'm going to do a couple more problems here, but feel free to go do your homework assignment. So given 8 moles of KClO3, and it's asking you to solve for liters. Okay, so theoretically, and theoretically doesn't really mean anything to you. Every math problem is a theoretical problem. How would it be an actual problem? You'd be doing an actual experiment. So theoretical is when you do a math problem. So how many liters of KCl? So I know my units are going to be liters of KCl. Can be made from 8 moles of potassium chlorate. So I start out with my 8 moles of potassium chlorate. Because it's in moles, that's over 1. I'm trying to solve for, what am I trying to, remember, it's the coefficient of the defined over the given. What am I trying to find? KCl, so that's a 2, over the given, which is also a 2. And the units I'm trying to solve it in, it's saying how many liters of KCl, so that's 22.4 over 1. So in my calculator, 8 times 2 times 22.4, I'm at the end of the road, so equal sign, divided by parentheses 1 times 2. Now, mind you, a lot of stuff could have been simplified here. You could see that 2 over 2 is simplified. So my answer actually is just going to be 8 times 22.4, because you don't have to actually divide anything by 1 to get the correct answer. So it's just 8 times 22.4, which is 130 liters, or 1.3 e to the 2 liters of that. There was 2 significant figures. That's why I rounded the number in my calculator to 2 significant figures. This 0 doesn't count as a significant figure without a decimal point there. So it's just 130. So 1.3 would be what the number would be if I were to put it into scientific notation. That's how you can tell that that 0 doesn't matter, is when you put it in scientific notation, there's no number right there. Okay. Theoretically, how many moles of KCl were needed to produce 6 grams of O2? So the question is how many moles? So that's what my units are going to be in. Are going to be in moles of KClO, that's a C, LO3. And they've given me 6 grams of O2. So how many moles is what I'm trying to find, and they've given me 6 grams. So 6 grams of O2 over 32, because they gave me grams, I've got to use molar mass of oxygen gas. The coefficient of what I'm trying to find over the coefficient of what I was given. The units I'm trying to find it in. Well, they asked me to find it in moles. So that's a 1 over 1. So my answer is going to be 6 times 2, if you'd like, times 1. I'm at the end of the road there, so hit equal sign. Divided by parentheses, 32 times 3, end parentheses, equal sign again, and you will come out with the answer of 0.13 moles. I needed 2 significant figures because my question gave me 2 significant figures. That's how I knew which numbers in my calculator to use when I wrote it down. Okay. What is the theoretical yield of the molecules of NaCl from 22.4 grams of sodium? So what is the theoretical yield of molecules? So molecules of NaCl, that's what my answer is going to come out in. Be careful, don't abbreviate molecules moles, because it's not the same thing. Oops, I'm going to run out of space there. That's NaCl. That's what that says, but I got to the end of the page. All right, so they gave me 24.7 grams. That's 3 significant figures, by the way, for my answer. And they didn't set it all up for you. They just gave you the problem here. Oh, they're going to show it to me now. So 24.7 grams, that's the number that they gave you. Because they gave you grams, you need the molar mass of sodium. The coefficient of what you're trying to find over the coefficient of what they gave you. So you're trying to find NaCl, so that's a 2. And they gave me Na, so that's a 2. The units I'm trying to find it in is molecules. So that's 6.02 times 10 to the 23rd over 1. So I can, technically speaking, cross those 2 things out. That makes my problem 24.7 times 6.02 times 10 to the 23rd. I'm at the end of the road, so equal sign divided by 23, because I already canceled that number out. If I leave those numbers, please don't forget to put parentheses around it if you are doing it by putting all the numbers in, and if you're not crossing anything out, you need parentheses around the bottom. So I needed three significant figures, 1, 2, 3. That's why they gave it to me in three significant figures here. All right, what's the theoretical yield in grams of water? So what am I trying to solve for? Grams of water. You see how I already know what it is that I'm solving for. And the units that they gave me in is 27.3 grams of C8H18, which is octane. So I'm going to put my 27, that's what I'm trying to find, over what I was given. The number always is attached to what you were given. So if they gave me grams of that, I got to go look that up. I got to go look up carbon. It's 12 times 8 plus 18. That's a times. So 12 times 8 plus 18 is where I'm getting 114 grams from. The coefficient of what I'm trying to find, that's an 18, over the coefficient of what I was given, that's a 2. And the units I'm trying to solve it in is water's molar mass. So water's molar mass is 16 plus 2. That's where the 18 is coming from. It has nothing to do with this 18 right here. That's total coincidence. That's the coefficient. But this is the molar mass of water. So oxygen is 16, and each hydrogen is 1. So there's 2 of them. That's where this 18 is coming from, this one. Okay, over 1. Now there is some simplification you can do. You can, if you wanted to not have parentheses down here at the bottom and you only want one number, you can at this moment say, oh, well, I know that that's the same thing as 9 over 1, and then I only have one number at the bottom. If you're math savvy, feel free to do all of that. If you're not math savvy, then don't do that and just use the calculator to do all your work for you. So 27.3 times 18 times 18, you're at the end of the road, so hit equal sign, divided by parentheses, 114 times 2 end parentheses, and you're going to get the same answer as the math savvy person that did all the cancellations. So just, if you don't know, just put it all in your calculator. It's going to do the work for you. Now, how many digits will my answer be? 3 digits. So that's why my answer is 38.8 grams of water. Okay, so more practice, but if you know what you're doing, feel free to go away and solve your problems. So they've given me 27.3 grams of carbon dioxide, and how many molecules of this is the question, are theoretically yielded from how many molecules? You see how that's a question? How many molecules? That's what I'm trying to find. So my answer is going to come out in molecules of C8H18. They gave me 27.3. So that's my given and that's my find. So grams of CO2, that's where I'm getting the 44 from, because if they gave me in grams, I got to do molar mass of CO2. The coefficient of what I'm trying to find is a 2 over the coefficient of what I was given, which is a 16. The units I'm trying to find it in is molecules, and that's over 1. So let the calculator do the work for you. 27.3 times 2 times 6.02 times 10 to the 23rd. You're at the end of the road, so hit equal sign, divided by parentheses 44 times 16 end parentheses, and equals. How many digits will my answer have? My number that they gave me is 3 significant figures, so my answer is going to be 3 significant figures. All right, don't forget your units. It's molecules, please don't abbreviate it moles. Molecules of C8H18. So how many molecules of CO2 can theoretically be produced, yielded from 27.3 moles of octane? So I'm going to start out with my number 27.3, and I'm going to answer in molecules of CO2. So they gave me 27.3 moles of this business. So what do I use as the conversion factor when they give me moles? 1. The units that I'm trying to solve it in, So what am I trying to find is the coefficient I'm going to go get. So molecules of CO2. So that's what I'm trying to find. So that's where the 16 is coming from. Over the coefficient of what I was given, that's where the 2 is coming from. The units I'm trying to solve it in is molecules of CO2. So that's 6.02 times 10 to the 23rd over 1. Let your calculator do your work. 27.3 times 16 times 6.02 times 10 to the 23rd equal sign divided by parentheses 1 times 2 and parentheses equal sign. How many digits will my answer have? 3. So my answer is 3 significant figures. And my answer comes out to 1.31 e to the 26 molecules of CO2. All right, so when 27.3 liters of this are burnt in the presence of oxygen, theoretically it yields how many molecules? How many molecules of CO2? So this is what I'm trying to find, and this is what I was given. So when I'm solving a problem, that's what I do for myself, is I figure out what am I trying to find. That's the units. It's going to be molecules of CO2 when I'm done. And I'm going to start out with 27.3 liters of that. So I look for the two pieces in my problem that I'm going to solve for. And so go ahead and calculate this problem. I'm going to pause the video. Well, you're going to pause the video actually, and then you're going to come back to see the answer. Okay, so the answer to your question should have been 5.87 e to the 24 molecules. This is the setup you should have had. It was 27.3 liters. Since they gave you liters, it was over 22.4. The coefficient of what you're trying to find is 16 over the coefficient of what they gave you, which was 2. The units you're trying to solve it in is molecules over 1. So you should have solved this problem and gotten this answer, and you rounded it to 3 digits because the number that they gave you was 3 digits. All right, remember that the theoretical yield is the number that you're getting from a problem, that math problem, versus the experimental or the actual yield. The experimental or the actual yield is you would have had to have done an experiment, actually solved the actual experiment to get the experimental yield. So every time we solve a problem in this class, it's going to be a theoretical yield. So the math calculation is called the theoretical yield. When you conduct an experiment, it's called the experimental or actual yield. Okay. Why would they not come out the same? Why would the math problem not come out to the same number as the experiment? Well, there could be competing reactions that are happening during the process that are messing up the efficiency of your equation. Your experimental conditions might have not been maintained perfectly, and your reactants that you're having aren't pure. So for example, if the question said you had solid copper, but when they mined the copper, you didn't have pure copper, then your reaction isn't going to come out exactly the same because the other elements that are in the copper are having reactions of their own. And in that, in turn, is going to affect the outcome. So theoretical yield and experimental yield are not always the same. Matter of fact, typically they're not the same. So how do you know what the theoretical yield is? It's always a math problem. And the experimental yield is a result of an experiment. We're going to need to know that for a future lesson.